Chapter 2 in your textbook. We've already reviewed portions of this that involve properties of addition, multiplication, and subtraction and division, so we're going to fly through those pretty quickly. The first topic to cover is absolute value. Absolute value tells you how far away a given number is from 0 on a number line. So the picture shown below illustrates that the number 2 is 2 steps away from 0 on the number line. It happens to be 2 steps above. So the absolute value of 2 is 2. This also shows you that the number -2 is 2 steps away from 0 on the number line. It happens to be 2 steps towards the left or in the negative direction, but still the absolute value of -2 is still 2. Absolute value is a measure of distance. So when you take the absolute value of a number, no matter what number you start with, once you take its absolute value, the answer you get is positive. Absolute value doesn't change the sign on a number all the time. It simply removes any negatives from a number. So the absolute value of -2, we lose the negative sign, and it's simply 2. The absolute value of +2 is still 2. In math, when we use the word opposite, we mean a number that has the same absolute value but a different sign. So this is easiest to show you with some examples. The opposite of 8 is -8. Both 8 and -8 have the same absolute value, but they have different signs. One is positive and one is negative. The opposite of -5 is +5. Again, they have the same absolute value, but different signs. The opposite of the absolute value of -5 is -5. How does that work? Well, look at the expression, the absolute value of -5. If you take the absolute value of -5, what you get is +5. And the opposite of +5 is -5. It is always true that the sum of a number and its opposite is 0. So -5 plus +5 is equal to 0. This is a property that we've already learned about. This is the 0 property of addition. We also called it the inverse property. When we went through properties of addition in a previous lesson, we learned about the commutative property that says you can change the order you add numbers, the associative property that says you can change the way you group numbers in a sum, the identity property that says if you add 0, you don't change the value of a number, and the inverse property that says that if you add a number and its opposite, what you get is 0. We also recognized that some properties of addition didn't work with subtraction. For example, subtraction was not commutative, because the order does matter when you're subtracting numbers. However, we have this subtraction rule that says we can turn a subtraction problem, a minus b, into an addition problem, a plus -b. Once we've turned it into an addition problem, all the rules of addition, that it is commutative, that it's associative, etc., they all work. We also studied the properties of multiplication. Multiplication was both commutative and associative. It had an identity property that says if we multiply a number by 1, we don't change that number. It had a 0 property, which says that if we multiply anything by 0, the answer we get is 0. And it had a property of -1 that says if we multiply a number by -1, we get the opposite of the number we started with. The way I think of this is if you multiply a number by -1, that has the effect of switching the sign on that number. So a times -1 gives you -a. If you start with -2 and multiply it by -1, that switches the sign on the -2 to make it +2. Oftentimes, we'll find that we need to switch the sign on a number, and what we'll do is we'll multiply it by -1. If that's part of an equation, we'll just simply multiply both sides of the equation by 1 because of the multiplication property of equality. We also noted that division did not follow many of the rules that multiplication did. For example, division is not commutative. The order that we divide two numbers does matter. But we noticed, first, that we have this inverse property of multiplication. That said that if we multiply a number by its multiplicative inverse, also called its reciprocal or its upside down, that the answer we get is 1. So a times 1 over a was 1. 8 times 1 over 8 was 1. And we had a division rule that used the inverse property of multiplication, and it said that we can turn a division problem, a divided by b, into a multiplication problem, a times 1 over b. And when we do that, all of the rules of multiplication apply. A times 1 over b, that's a multiplication problem, so we can apply the commutative property and the associative property, etc. All right, switching gears for a minute. Here's a math problem, and I'm going to ask, can you do this in your head? And some of you are very good at mental arithmetic, and you're able to remember a number of things at once. And so maybe you're doing some multiplication by parts in this. Maybe you're trying to remember the sum of 500 plus 45 plus 10 plus 40 and add those all up in your head. Maybe you look at this and say, nope, I can't do that in my head. What I'll suggest to you is that if you're doing any of that kind of thinking, it's good mathematical thinking that misses a much easier way to do this problem. So one way you could do this problem is, in your head, you might be able to multiply 5 times 192, and that gives you 960. You probably know that 5 times 8 is 40, and you can add those two up and get 1,000. But a much easier way to do this problem is to apply the distributive property in reverse. So if you look at the equation up above, 5 times 192 plus 5 times 8, that looks like what you get if someone started out with 5 times the quantity 192 plus 8 and then applied the distributive property. But 192 plus 8, that's just 200. And 5 times 200, you can do that in your head. That's 1,000. We're using something called the distributive property to do a little bit of mental math here. And very often that's one of the more useful applications of the distributive property in everyday life. So again, the original equation that I gave you kind of looks like the result that you would get if someone had applied the distributive property to the expression 5 times 192 plus 8. That 5 outside the parentheses would get multiplied by the 192 and by the 8. It's important to notice that we only apply the distributive property when we have multiplication over addition. So that means we're multiplying something, that's the number outside the parentheses, by a sum, 192 plus 8. Now remember, the stuff inside the parentheses might look to you like it's a subtraction problem. It might be 192 minus 8, but you can change it into an addition problem by adding a negative. Here's another way to see the distributive property. On the left, I've shown you a picture. And the red blocks represent the product of 5 and 3, 5 times 3. If you count them up, you would see that there are 15 red blocks. The green blocks represent the product of 5 and 2. It's 5 rows times 2 columns. There's a total of 10 green blocks. So on the left-hand side of the equality, we have a picture that goes with 5 times 3 plus 5 times 2. On the right-hand side, I've showed you an undistributed version of the same problem. And what I've done is I've grouped the same number of red and green blocks into 5 equal groups. That's the 5 outside the parentheses. So there's 5 equal groups there. And within each group, we have 3 red blocks plus 2 green blocks. When we're applying the distributive property, all that we're really doing is adding up all of the total blocks, the 5 sets of 3 red blocks and the 5 sets of 2 green blocks. And altogether, we end up with 25 blocks. The word distribute, if you look it up in the dictionary, it says to spread out so as to cover something. It might be helpful to think about taking the number outside of the parentheses, the 5 in the previous example, and spreading it out so that it covers all of the stuff inside the parentheses. In the language of algebra, the general form for the distributive property says that if we have A times the quantity b plus c. We can rewrite that as a times b plus a times c. Likewise, if we have a times the quantity b minus c, we can write that as a times b minus a times c. We'll do a lot of work this year running the distributive property in both directions. So sometimes we'll start out with the a already outside the parentheses and multiply it by each of the things inside the parentheses. And sometimes we'll start out with expressions that look like the ones on the right-hand side of this page. And we'll figure out what number can we factor out of both terms and pull it up towards the front of the parentheses. How do we undistribute something? Last, let me show you a common mistake that people make as they're learning about the distributive property. You might see a problem that looks like this: 3 times the quantity x times 2. You see a number outside the parentheses, and then you see the x and the 2 inside the parentheses, and you think, aha, I'd best apply the distributive property. And so you draw your little arrows in, and you say it's 3 times x times, and then you think to yourself 3 times 2 is 6, and you know that 3 times 6 is 18, so the answer must be 18x. This is wrong. This is not correct. What you've done here is you've applied the distributive property to a problem that was not multiplication over addition. Let me show you the right way to do this problem. 3 times x times 2. What we have here is a multiplication problem. We have 3 numbers multiplied together, 3 times x times 2. Right now, the x and the 2 are grouped together, so we're going to multiply those first. The associative property says it doesn't matter which 2 of those 3 numbers we multiply together first. So I could switch the order around using the commutative property. I could multiply the 3 times the 2 first using the associative property. And 3 times 2 is 6, and 6 times x is 6x. So this is the right way to do this multiplication problem. What you probably had in your head when you made the mistake that's shown on the left and labeled as wrong was a problem that looked more like this: 3 times the quantity x plus 2. This is an appropriate time to use the distributive property. We have multiplication, 3 times, over addition, x plus 2. So 3 times the quantity, x plus 2. Here is where we would apply our little arrows over the top. 3 times x is 3x, plus 3 times 2 is 6. 3x plus 6, that's as simplified as we can get it. This is a correct use of the distributive property. So just be careful that you don't jump to using the distributive property when you shouldn't. This is the end of this lesson.